So let's continue with our Stack and Cube playlist. Today for starting off, hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So the problem that we will be solving today is trapping rainwater. So what is the problem stating? It's stating that you will be given an array of non-negative integers, where every integer is representing the height of a given building. The height can be 0 as well. Now imagine if it rains, there'll be water from the sky, correct? And if there is water from the sky, there'll be water logging as well. There'll be water logging all across. I'll have to figure out where will be the water logged. So in this particular case, I can surely see that there'll be some water logged over here. There'll be some water logged over here. We might ask, why not over here? It is a flat surface, so what will happen is the water will flow to the streets. It is a flat surface, so the water will flow to the streets. So when it rains, the water gets logged only in between the buildings. Now your task is to tell me the total units of water that might be stored in between the buildings. So can I say that like this particular building has 1 unit of water? Why 1? The base is of width 1 and the height is of width 1. So 1 into 1 is 1 unit of water. Now, there is a lot of water over here. There's a lot of water over here. So how do I figure out the total units of water? Quite simple. You look at the first building and you see how much water is there. That's 1. You look at the second building and you say there is 2 units of water on the top of it. You look at the third and you say that there is 1 unit of water on the top of it, which makes it a total of 4 units of water. And the last one has 1 unit of water. So in total, I have 6 units of water. And this is what you will have to return. Okay. How do I solve this particular problem? Like, what is the brute force that comes to your brain? First of all, let's understand where will the water be stored? It will only be stored if I have a building and there is a taller building on the left and there's a taller building on the right. Then only water can be logged. That's for sure. Like in this particular case, there was no water logged because there's no one on the left which is taller. On the left, on the right, there has to be someone taller for water to be logged. So one thing I've understood that I need taller building on the left. I need a taller building on the right. Then only water will be logged. Okay. Next thing, like the thought process, the intuition. I see water being logged over here. How did I figure out the total units of water? What I did was, I looked over individual buildings. So for this building, I had 1 unit of water. For this building, I had 2 units of water. For this building, I had 1 unit of water. And overall, I added them up to get 4 units at this particular place. So if I need the total units of water across all the buildings, can I say I'll go to each building's terrace and figure out how much water is stored, and I can sum it up, and that will be my total. I'll go through each and every building and I'll figure out how much water is stored on the top of that building. Okay, the second one is clear as well. Now the question arises, for every particular building, how do I know how much water is stored? Okay, good question. Let's understand that by taking this particular building. So if I look at this building, this has a height of 1 and this is storing water because on the left I have someone of height 2 which is greater than it, and it is also storing water because on the right it has a height of 3. It has a building which has a height of 3 which is greater than it. Okay, on the left I have someone greater, on the right I have someone greater. But why is it storing only till here? And why not till here? Because there are other waters, like it will overflow. It will just go into the streets. Okay. So this was of height 2 on the left. This was of height 3. How much water did it store? Till the height 2. The lower of the left and the right. So can I say it looks onto the left, it looks onto the left and figures out who is your left max, and it looks onto the right and figures out who is your right max. Can I say this? It does that for sure, right? And then it says, okay, I have two max, like I have a max on the left, I have a max on the right. Now I'll take the minimum of it because that is the height till where I can have water. Okay, but how much? It can only store water from the height of the building, correct? So this was 2. So 2 minus the height of the building was 1. So it ended up storing 1 unit of water. So can I say minus the height of the building, which is array of I? So can I say this is the formula for every I, and if I could go over, my bad, if I could go over from 0 till n minus 1, and I can do it for every building and sum it up, I think I'll have the total units of water. I will have it for sure. The only thing I'll have to figure out is how do I find left max? How do I find right max in the most optimal manner? That is what I'll have to figure out. So before I move on to the code, there is a key thing that you'll have to keep in mind. The left max and the right max, both of them has to be greater than array of I. Then only it can store water. Like if it is in between two bigger buildings, then only it can store water. So keep in mind, okay? So I'll have to write down the code. So what I will do is, I will take total equal to 0. Okay, total equal to 0. I'll start iterating from I equal to 0 till n minus 1. Perfect. Now what I will do is, I'll say, okay, I'm at index I, the building I. So if my array of I is lesser than my left max, how to figure left max? I'll do that afterwards. And my array of I is smaller than right max. In that scenario, I'll have some water. I'll have some water with me. And what is the formula? You know the formula, right? Total plus equal to minimum of your left max, comma, your right max minus array of I. And that would be done for this one. If this if condition is not meeting, then it will be 0 units of water, which you don't have to add. And eventually, you could end up returning the total units of water. Perfect. But now the question arises, how do I figure out the left max and the right max? What is left max? If I'm standing at here, the left max is nothing but I'll have to go entirely towards the left and figure out the left max. And the right max, I'll have to go through each and every element on the right and figure out the right max. But is there a better way? Yes, there is a better way. It's known as prefix max. It's known as prefix max and suffix max. Prefix max. So you can define you can basically define a array of size n, and similarly for suffix max, you can define a array of size n. So I'll take a small example and I'll explain you. So imagine you have an array which looks something like 2, 1, 0, 5, 3. So what prefix max does is, it's super simple. It says prefix, the first element, the prefix of 0 will be array of 0, which is 2. Okay. After that, it comes to this element and it says you have a 1. You have a 1. So whenever I'm standing at this index, I need the maximum of these two elements. Maximum of these two elements, which is the max of 1 and the max of 2. Thereby, I say 2. Perfect. After that, I go to the next. Now, when I'm standing here, I'm saying I need the prefix max of these 3 elements. The definition of prefix is the maximum till that index. The maximum of all the elements till that index. That is prefix. Got it? So if I need the prefix max for this one, I'll have to take the max of 0, 1 and 2. Or can I say I have stored 2 over here, which means the max of these 2 elements So I could simply compare 2 and 0. That will be 2. Perfect. After that, I'll go to 5. So when I go to 5, I need the prefix max of the 4 elements, which is typically, till here you have 2, which is all the 3 elements, prefix max is 2, and then you can compare it with 5. Okay, so you get 5. After that, you go over here, which means you need all the prefix, like max of all the elements. So what you could do is, you could take these 4 elements, which is nothing but this one, 5, and then compare it with 3. Thereby, it still stays as 5. So now at any moment, if you come over here, you know that towards the entire left arena, the maximum is 4. If you come at this place, you know towards the entire left, the max is 2. If you come at this index, you know the left max is 5. So you always know about it. It's very simple. How you write this is, you basically say prefix of 0 will be array of 0. And after that, you could just start with I equal to 1, and you could go ahead till n minus 1, and you could do prefix of I equal to max of prefix of I minus 1, comma of array of I, and that would be your prefix I. So can I say this? I do have my left max now. You could relate, and I'll show you in the code afterwards, but let's quickly check out the suffix max as well. It goes in the reverse direction, suffix, because I'm looking for right max. So maybe I can take an array, and let's assume the array is something like 10, 2, comma, let's say 11, comma, let's say 1. Perfect. So what you do is, you take a suffix max. Let us suffix max, yes. And you basically fill up the last element. So the last element will be 10. Then you come to this element and you say, I need the max of these 2 elements. So you still have for 1, so 10 comma 2. The max will be 10. Then you again go over here. This time you say you need the max of 3 elements. So till 2 elements you have it here, and then you compare it with this. So that ends up becoming 11. After that, for this one, you end up taking 11. So you have the suffix max ready as well. You could come to any index and you'll get the right maximum. You'll get the right maximum from that index. Super simple. So what I could do is, I have to write the code. I think it's going to be same. You'll have to do suffix max n minus 1. The last element can be filled. Array of n minus 1. And once that is done, you could start traversing from n minus 2, very important, till 0 in the backward direction. And you could say suffix max is equal to max, suffix max of I is equal to max of suffix max of I plus 1, comma, array of I. That's it. That is as easy as it gets. So you have the suffix max ready, you have the prefix max ready. So can I say, I can easily figure out the left max now. What will be left max? So left max will be nothing but prefix max of I, and right max will be nothing but suffix max of I. Please make sure before these for loops, you should have done these things on the array. You should have done these things and computed the prefix array and computed the suffix array. Once you'd have done that, you could do this. Okay, so crucial time to analyze the time complexity of this one. So if you look at the prefix max, this is hardly taking a bgo of n. The suffix max is also taking a bgo of n, like to generate. So can I say I'm consuming bgo of 2n in order to generate prefix max and suffix max? And then there is another bgo of n in order to compute the total units of water, which is another bgo of n. So in overall, it's near about bgo of 3n, which is as good as bgo of n. What about the space complexity? I'm ending up using a couple of arrays, one to store the prefix max, while the other one to store suffix max. This can be optimized. Like I'll leave that to you as a homework. What if I don't take prefix max? I can still do it just with the suffix max. Just with the suffix max, this could be done. So the space complexity could be reduced to one array as well. I'll leave that as a homework. It's very simple. You just have to do one thing while you're traversing. Remember the left max. Remember the left max while traversing, and that will be done. I'll leave that optimization to you. It's very straightforward. So this is the time complexity and space complexity. So the interviewer will not be happy with the extra space that you're using, and he will ask you to optimize this one. So we need to optimize our previous solution. Now the previous solution was taking a big O of n space complexity. I have to optimize it. Now this is a clear indication that we are looking for something around big O of 1 space complexity. Why were we taking big O of n space? A simple, whenever we had a building and we had to figure out the units of water on the top of it, we figured out left max, we figured out right max. The figuring out left max was super simple because we were traversing from left to right. But in order to figure out right max, we used something as suffix max, right? And that is what was taking a big O of n space complexity. So I'll have to optimize. So for every building, the formula that we were using was minimum of left max, comma, right max minus array of I. And this was for every building. And we ended up summing it up. Obviously, given that array of I has to be greater than left max and right max for it to have some water on the top of it. Okay. So now let's understand one thing. If you're standing at this particular building, you're at this building and the water is here. The water is here. Now if you have to compute the units of water, now there is something as left max, there is something as right max. But do I need the right max? Do I need the right max? No, because the units of water is 2 minus 1, where 2 is left max and 1 is array of I. I just need the left max. I just need the left max. I don't need the right max. And this is the intuition that I will be using. I know one thing for sure. I either need the left max or I either need the right max. I don't need both of them. If I have one of them and the smaller one, this is very, very important. I always need the smaller one. It can either be the left max, it can either be the right max. And this is what I will be using in order to optimize. Keep it in mind, we always need the smaller one because the smaller one is the building till which I can have water. Got it? Okay. So I know this intuition. How do I solve it? First of all, if I do a left to right traversal, it won't be possible because imagine you're standing over here. You have never seen what is on right. You have never done anything around it. So that is not possible. If I traverse from right to left, then also you have never seen the left portion. Somehow I'll have to do a two-way traversal. This is where the thought process comes in. Maybe I could try a two-way traversal. Okay, left pointer and right pointer. And at the same time, what I'll do is I'll take a left max and I'll initialize it to be 0. I'll take a right max and I'll initialize it to be 0. And I'll take a total and I'll put it as 0. So initially, left is at 0 and the right is at 1, which is typically the 0th index and the n minus 1th index. Okay, so when we start off, remember, smaller one is what matters. Smaller one is what matters. So we are at a building with height 0, we are at a building with height 1. Which one do we work on? We cannot work on both simultaneously. So we'll work on the smaller one. We'll always work on the smaller one. So we'll take this one. We'll take this one. Now I know this is smaller than this particular thing, which clearly gives us an idea that on the right, I have a taller building. On the right, I have a taller building for sure. Now what I need to do is figure out, do we have something on the left? Do I have something on the left? And I see that on the left, I still don't have anything. Thereby, I cannot store water in it. Hence, I will move. I'll go to the next. Nothing updated because it is 0. The left max doesn't get updated. Now I'm at this one. and I'm at this one. Both of them are same. Both of them are same. If both of them are same, I can straight away say that I'll probably work on L. You could work on R as well. You could do something on R as well. Doesn't matter. But I will work on the L. So if I'm at this one, I know on the right I have something similar. Something similar. Okay, fine. So if I have something similar, I can definitely not store water. But still, I'll look on the left. And when you look at the left, you also don't have anything. So what you'll do is you'll update the left max. You could do that. Now you go here. Now this is the moment you need to understand something. You're at the building with a 0 height, and on the right you're at a building with the height 1. On the left, nothing is greater than 1. Nothing is greater than 1. You never saw a 2 because that will never happen. I'm traversing by making sure I always traverse through the smaller ones, So it will never happen that I'll traverse 2 first and the 1 will be left out. I repeat, it will never happen that I traverse 2 first and there'll be 1 left out because I'm traversing the smaller one first. You'll understand as I move forward. So I have a 0 now. I have a 0, I have a 1. So I'll always do the smaller one. So I have a 0 and I know on the right I have a 1. On the right I have a 1. I need to look on the left. On the left, I see that the left max is 1. If the left max is 1, and I know the right is greater, it's going to store. So I'm very sure about one thing, that I can store some units of water. And that unit of water will be 1, which is the left max, minus 0. Why? Very simple. If this is 1, and I'm very sure anything to the left of 0 can never be greater than 1. Because I'm traversing the smaller ones. Perfect. After this, I move left to 2. At the moment I move left to 2, I'll never traverse this because I'll traverse the smaller one. So I will end up traversing this one. Perfect. I look at the right. Do I have something? No. I update the right max to 1 and I move right. This time I have a 2. So I'm very sure about one thing. Everything on the left will be lesser than 2. The buildings on the left will be smaller. Keep that in mind. The buildings on the left will be smaller. So what will I do? Will I take this 2 or this 2? You can take either of them. So I'll take this, and what I'll do is I'll update 2. Because on the left, there is nothing which can store water. So I'll just move ahead. Again on the left, I'm at a 1 and I'm at a 2. So which one will you do with? You'll do with this one. You will do with this one. And at this moment, you have a 2. On the right max, you have a 1. So you cannot store water. So you'll just update your right max and it'll move ahead. At this point, you are at this place and you're at this place. And you are sure about one thing. Whatever max you have on the right, that is something, like you cannot have a 3 here. Because you're traversing the smaller ones first. Keep that in mind. So you have a 1. And on the right, you know that the right max is 2. So the right is supported. You just need to look at the left. The left max is 2. So you can store water. How much? Left max is 2. This is 1. So 1 more unit. After that, you move left to 0. This time when you move to 0, you know on the right you are supported by 2. Right? So you look at the left. There will be something which is around 2. And you see the left max is 2. It will never be 3. Because you're traversing the smaller ones first. So since I have the left max to be 2, I can say the units of water will be 2 minus 2, 2. So 4. And then I'll move here. Now when I move here, again, I know the right max is 2. So the right is supported. I look at the left. The left max is 2. So the unit of water will be 1 minus 2. So you update. And again you move left. This time you come up to be at 3. You are at 3 now. Okay. So you'll end up doing things on the right. Traverse the smaller ones. So whenever you are at here, you know there is someone on the left who's there, who's greater. Okay. So you look at the right and you see that on the right there is a max. And that max, this max, will always be lesser than this buildings. Like you'll never find a 4 here. Never. Right? So this max is 2. And so the unit of water will be right max minus 1. That is 6. And then you move out. Again, the same thing, you'll traverse with this one. You'll look at the right max, which is 2. Unit of order is 0. So you move and you move it here. So when you move there, left and right will always end up at the largest, and whenever they end up at the largest, you stop. And when you stop, the total units of water will be storing your answer. Yes, that is it. It is important to traverse the left ones, the smaller ones first, so that you could easily deal with it. Okay. Time to write down the code now. So if I have to write down the code, it's super simple. I need to return an integer. So an integer and a function will be, maybe I need find total water. So find total. I'll be given an array. Perfect. I'll start writing. What do I need? I need a left max. I need a right max. I need a total. And all of them assigned to be 0. And I need a left pointer assigned to be 0. And a right pointer assigned to n minus 1 for sure. I know I'll go ahead till I don't reach the largest element, which is L lesser than R. Now, if array of L is lesser than equal to array of R, I can deal with array of L, because I know for sure on the right I have someone who's greater, or at least of the same length. So I'll be like, okay, hey, first thing, if my left max is actually greater than my array of L, which gives me an idea that I have someone on the left, thereby the total can be increased by left max minus array of L. But if it is not the case, if you don't have someone who's greater, obviously this person itself is the greater, so you could just update it. And once you've done this, you could move the pointer to the next one, which is L plus 1, and that would be done with the F. Can I write the else? I can. So you'll just write an else. What will be else? Else will be similar. It'll be like if, because you're dealing with a small element now, if right max is greater than array of right. If that's the case, I'm very sure total plus equal to right max minus array of R, or else you will end up updating right max to array of R, and once that is done, you'll be doing a back iteration, R equal to R minus 1, and once everything is done, you could finish up the while loop and you could typically return the total value, and that will be it. What is the time complexity? If I go back, the left pointer and the right pointer together will move n indexes, right? Not beyond it. So this while loop at the worst possible scenario will move, not even worst, it will move big of n. Thereby the time complexity is a big O of n, and the space complexity is a big O of 1, because I'm not using any external space. And this is the most optimal solution. We can't do better, because I'll have to touch every element at least once. Without that, I cannot solve it. So this is the best possible solution. So I hope you have understood everything. And if that is the case, please do consider subscribing to us. And with this, I'll be wrapping up this video. Let's meet in some other video. Till then, bye. Take care.
Whenever your heart is broken.